Hello, we're back. Welcome to another CleaveTech tech tip, and this time we're continuing our build of our Genesis chassis for the INTRO32 class at the Clubman Nationals. If you haven't seen the previous video, have a link up here and click on that and watch that first, because that's how we got to this stage. So today the chassis was ready and we're about to install the motor and get a gear mesh. So I've got my list of parts here. We've got a pinion, we've got our axle, we've got screws to hold the motor in because we're not allowed to solder the motor in. We've got a Mid-America Eagle motor, here we are, and we've got our angled spur that we have to use. So the gear ratio is fixed and we have to stick with that, and the chassis is designed to match that gear ratio. So let's get going. The first thing I'm going to do before I put the motor in is you can see how round this pillar block here the bushing is just a little bit of a bigger diameter than where the pillar block is trimmed off to. So I'm just going to grind away a little bit of the bushing on the outside because it makes it easier to install this motor screw here. It can be done with a full bushing like this, but just grinding off a very small amount of this bit of bushing that's sticking out over the edge of the pillar block will make it a lot easier. Bearings or bushes are free choice. They can't be ball bearings, but they can be bushes of your choice. So you are allowed to grind a little bit out of the bush, but not obviously grind loads away from the chassis. So that's where my little diamond bit is going to come in nicely. I showed you this in the previous video, but again, there's links down below where you can get all these tools from. But I'm going to use that just to grind away a little bit like that in my Proxon rotary tool. So there we have it. I've just ground that little bit of a bushing away, and it gives us just so much more room to get that screw into place. Now we're going to test fit the motor. Now the rules say the motor has to be installed with any motor designations like this Mid-America Eagle visible from the bottom of the chassis. So the motor generally just drops in like that, so we can see the Mid-America underneath. Let's just install that the right way, like so. Mid-America designation underneath, and then when you put the motor in, it's worth checking how that motor sits in the chassis. So looking underneath now, especially at this back edge, you've got to check that the back of the motor doesn't hang down below the chassis. Okay, I've seen lots of people install them, either with a motor slightly sideways like this. But anyway, this support at the back of the motor should support the motor so that it doesn't hang down below the chassis. If your motor does hang down below the chassis, then you might have to just reflow this solder joint at the back here to just try and hold the motor up a little bit at the back. And you can just check it again at the front. There's a very fraction difference there, but when I put the screws in, I can make sure that that sits nicely in there. So I know the motor's going to sit nicely on this chassis, which is a good start. So the next thing I'm going to do, I'm just going to slide the gears in place. So this pinion gear slides on nicely. And this one's a mid 6411, so I assume that means 64 pitch, 11 tooth, but it also has a 2mm bore on it to match the motor. And then we can also have a look at the angled gear. So slide the axle in, have a look at the angled gear and how that sits. Might just need to slacken off that grub screw a bit. And there we go. So at this point, the angled gear is a little bit too big, and you can see how it's rolling. When I roll the chassis, it does stick below the chassis a fraction. So I'm going to have to take the tips of the teeth off the angled gear. The other thing I'm looking at is if the gear goes all the way back to that bushing, which it should do, you don't really want any washers in between, because if you have washers in between the gear and the bushing, it just makes it an absolute nightmare every time you've got to change the gear. Because if you've got to do it in a hurry and you're pulling your axle out and you're putting it in, you've got to get the washer back in between, it's an absolute nightmare. So ideally you shouldn't have any washers behind that bushing or behind the gear or in between the gear and the bushing. I also then want to see how well does the gears actually mesh. So here we go. So let's have a look. So the motor's sitting there. The gear is all the way back to the bushing. Again, I don't want excess pinion sticking out the front, so I don't really want it to be like that, because by the time I put my tyre on and it's taken up that width, the gear is going to be into the tyre, so I don't want that. So I only want the pinion to be sticking out as far as the gear itself, the edge of the teeth, so I can remove all of this excess bit of shaft. And that's sort of where I wanted it to sit. And then we just double check, how is that gear mesh? There's a tiny bit of play in the gears, but you're fine with that. You actually want a little bit of play in these angled gears. If you mesh them too tightly, then they'll actually sound rather horrible and sap a lot of your power from your car, from the motor. So again, you don't want them too tight to mesh. And as I say, these chassis are designed for these gears to match. Now, first of all then, let's have a measurement and let's see how much shaft I need sticking out. So here we have it here. So let's put that on there. So if I measure to that bearing face there, I'll bring it in a little bit closer so we can see here. And I just push my calipers in like that. So you can see now how I've got that distance, or you could do it like that if you want to. There we go. So just a little bit more shaft than I need, just to allow the gear to go on. And we're talking 4.46 or 4.5 millimeters, let's say, of shaft sticking out would be plenty of shaft to allow me to attach the pinion. So I'm now going to go and cut that shaft off a little bit shorter. So I've just marked the shaft with a pen at 4.5 millimeters out from that bushing face. And then when I'm going to cut it off, I'm just going to poke the motor shaft through a little bit of tissue paper like that. And then I'm going to hold the whole motor in my hands like this. And I'm going to try and hold the armature shaft as well, so I can sort of hold it through those holes gently there. But basically what that does is it just stops all the bits that I'm cutting from sticking to the motor. So I'm now going to cut that off with a cut-off disc. So I've just cut that shaft off there to that distance there. I took it fairly easily because I don't want to heat the motor shaft too much, because that just puts excess heat through the windings and the bushes and everything like that. But you can see it's not perfectly square on the end, but that's okay, because what I'm going to do now is I'm just going to spin the motor up at around about 3 or 4 volts on my power supply, and then bring the grinding disc into the end and square the end up nicely, and maybe put a very small chamfer on the end, because it then makes it easier to get the pinions on and off.
12 seconds later.
So there we are, finished that off. It's nice and square, nice and good on the end. Small chamfer on there, which should make it nice and easy to get the pinion onto the shaft and slide it off again if I ever need to. Now, before I solder the pinion onto the motor, you can notice that the pinion is nearly double the width of the spur gear that it's going to go on, the angled spur gear. Now, I don't need all of that extra mass of tooth spinning round on the end of my motor shaft. So I'm actually going to reduce the diameter of the pinion on the bits of the teeth that I don't need and the bits of the teeth I don't use. So in order to do that, I'm going to solder this onto an old motor, just an old Falcon or something like that, or a Hawk, and I'm then going to grind away the teeth where I don't need them.
A few moments later.
So there we have our modified pinion. You can see I've just ground it down a little bit around there. And in fact, it looks a little bit like another make of pinion, but it isn't another make of pinion. It is the original Mid-America pinion. What I did find though is that actually this material that the pinions are made from is quite soft, which in one sense means it's not going to damage the spur gear too much, but we'll have to see how long it lasts and how it wears. But the material is actually quite soft. So let's get this pinion attached to the motor. So first of all, it can be a good idea just to run a little bit of emery paper or wet and dry over the motor shaft, because it just helps the solder take to the shaft. Depending on the material that the shafts are made from, some of the shafts tin better than others. So just going to connect it up to the power supply and just run a little bit of wet and dry paper over the shaft. Not a lot, just like that. you don't want to reduce the diameter of the shaft at all. You just want to clean it up a little bit. So now we can take a little bit of, don't know whether you can see it in my label now, maybe on the lid it's better, but it's Lucky Bob's Flux. I really like this flux. And then a little flux brush like that. You can run some flux over the shaft. Now, some people put a little bit of paper or card between the bearing and where I'm going to solder the pinion. That can help it in case you push the pinion on too far or you get solder running into the bearing. I'm going to be careful and I'm not going to do that, but that is a good tip. You could put a bit of paper or card in between, can help. So we take a little bit of solder on the iron and we just run it around the shaft like that. And then we can re-tin it or reapply the flux just on that last bit of the shaft there. And we just keep going round like this. Again, I'm not holding the soldering iron on the shaft for too long. And you can see that I've gone round and I've just literally soldered the bit that I need to solder. So now, sometimes you get these little black blobs, which is the flux out of the electrician solder that I'm using. So I'm just going to get rid of some of those, give the shaft a bit of a wipe and a clean, like that. And then we should be ready to install the pinion. So again, a little bit more flux on the end. And most of the time, the pinions will sit on the end of the shaft like that, just with a little press before you solder them together. So then, because there's plenty of solder on the shaft, for this point, I'm just going to heat the shaft and gently push the pinion on with my knife like that. I'm being careful not to put too much solder on because I don't want solder to go and flow into the teeth of my pinion. So I pushed it on, but because this is a fresh pinion, then what I would do is I would heat it up again, slide it most of the way off, not all the way, but most of the way off, and then I'd reapply some flux inside the pinion, inside the bore of the pinion. Okay, a little bit more on the shaft, just to make sure that the solder has taken all the way through that pinion and it's soldered nicely. There we go, push it on. Now, because I've cut the shaft to the right length, I should just be able to push it on and get it level with the end of the shaft where I want it, like that. So let's just take a little close look at that pinion. See, the solder's flowed nicely all around the end. I gave it a quick clean because we've actually used some acid flux on this. I gave the motor a good wash and blasted it out again to dry it off. I've also cleaned the block underneath because again that was where I was soldering, so I don't want any of that to get on my nice clean chassis. Now the best way to take the tips off the teeth is either to run the axle in your car and grind them off, or stick them on your tyre truer and just grind the tips off a little bit with your rotary tool. Now I just need to bring the gear down in diameter so that it's less than about 600. There we go, so bring it down to 594. Why 600s? Because that's the axle height that I set on the chassis in my previous video. Now because I've ground those tips away, you can see it's sort of folded the plastic over a little bit at the back. So I'm just going to clean that off with a little wire brush, and it just helps make the gear run a little bit more smoothly when it's back on the car. Now there is a guy in Sweden who makes a little tool that you can take the tips off the gear and you can use a knife to do it, and it spaces it nicely. But I haven't got one of those handy at the moment, so that was the best way that I can do it. And not everybody has one of those tools, but most people these days now have some form of tyre truer. So I'm going to use a little wire brush just to clean off those burrs on the back of the gear. And there we have it, all cleaned off nicely. So that gear should run nice and smoothly. Why didn't I just put the gear in my rotary tool and spin it round and grind it? Well, that's because the rotary tools, although they run pretty true, they generally don't run as true as your tyre truer would run. So that gives you a better trim of the gear all the way round, instead of the trimming maybe a little bit more on one side than the other. The other thing I've done before installing it on the car, as you can see, I've cut down the grub screw to make it a lot shorter and balanced the gear. So when I screw that in now, you can see that the grub screw actually is pretty much the same length as the boss on the gear. Now, balancing your gears can help your car run much more smoothly. It can give you more grip, more top speed, better acceleration, etc. If you haven't seen my video on balancing, I'll put a link up here in the top corner. It's a good watch. So let's get this motor installed in the car now and get the gear mesh and check it out. I've got my motor screws, my mid 108. They come in a packet, I think, but you only need 2 for this application. So let's take the motor. Remember, we've got to install it with righting downwards. So in we go. It sort of clips in there. Remember, I've already checked how the motor sits in the chassis to make sure that it sits correctly. Now, these have a little Allen head on them, little hex head. Now, I think, what size are they? Well, they're not 1.5. I've got a 1.3. That's a good fit. So a 1.3 millimeter is a good fit. Now, most of the tyre wrenches are 1.27 millimeters or 0.50s. But if you can get a 1.3, then you'll have a little slightly better fit in your hex head of these screws. And also, I would say that a 1.3 millimeter hex can also help you remove like damaged grub screws out of old hubs, etc., if you want to reuse them. So let's get that into there. It goes in nicely, fits in nicely into the motor. And the one the other side that I removed a little bit of that bushing to allow it to go in. In it goes. Sometimes it's easier to install the one at the back first, because then you can wiggle it in a little bit better past the bushing if you haven't ground enough away. But this one fits in there quite nicely. So I'm just going to leave the screws just a little bit loose to start with, so that I've got a little bit of movement in my motor. I don't know whether you can see, there is a tiny bit of movement there in the motor. I just want to make sure that any movement I've got, I can get a decent gear mesh. Slide the axle through, put my angle gear on. Just tighten that up there. Just nip it up, and then I can check my gear mesh. There is a very slight bit of play there, but I'm just going to push the motor into the gear as far as I can get it. Just tighten that first screw up there. There we go, that's nice. That's nice. And then I can remove the axle and tighten up the other screw there. Give them a good pinch up. There we go. And then I'll just bring it close to the camera so you can see what the alignment and the gear mesh is like. So there we go. Here's a close-up look. So you can see that because I measured that motor shaft nicely and where I've turned the gear down, the pinion is only the width it needs to be to match the spur gear. It's also worth just checking what's the end float of the motor like, and when the motor moves one way or the other, are the gears still in mesh? Because sometimes there's a lot of end float in these motors, but I've allowed just enough on that pinion just to allow it to stay in mesh. And then what about the backlash in the gears? Let's have a look. There's a little bit of backlash there, but that's fine for a 64 pitch angled gear. Obviously, if you were going to run 72 pitch, you'd have a little bit less backlash. In fact, hardly any. And then 80 pitch, again, really virtually no backlash at all in the gears because the teeth are so small. But this is fine for an angled gear, and that should run nicely. Now normally I would think that this axle's a bit long and trim it off, but the hubs we've got are going to be these hubs here. Now Mid-America products, they don't make 1/32 scale width hubs, which need to be about 16 millimeters. They actually make them at this width here, which is for 1/24 cars. So I'm going to have to cut them down, but they're not offset on the back. So ideally, you would use one hub that had an offset boss that was slightly inside, and then it slides over the gear, the boss of the gear. But we haven't got them. So when I cut these to width, I'm going to have one with the boss on the outside and then one with the boss on the inside. So I need to leave enough axle in order to be able to fix these wheels on and still be able to clamp them about here with a grub screw. So I'm going to leave the axle to be fairly long to start with. So what I've found with these Mid-America bushes is they need quite a bit of initial oiling because they really soak up the oil quite nicely. Especially as you've soldered them, you've sort of melted a lot of the oil out of the bushing to start with. So getting a nice good coating of oil on them and letting them soak the oil up is good. So just keep oiling them. I just want to do a nice little run though, just to hear that gear mesh and see how it sounds. So again, tiny little bit of oil on the motor, not a lot, because that throws oil out everywhere then. And again, you don't want to oil the com end too much because sometimes you can get oil on the com and the brushes, and that's not good. So I put a bit of oil on it, just spin it over a couple of times just to run that oil in, and I'm going to turn the power supply on, connect it, and then see how it sounds. So there we have it. Give it a few little revs. I'm quite happy with that. Seems to run over quite nicely. Something I did mention earlier when we were looking at test fitting the motor, but I didn't mention it when I actually put the screws in, is obviously to make sure your motor is nice and flush with the bottom of the chassis and not sticking up in the air or hanging down below the chassis. Obviously, if you install your motor with a chassis sitting on a flat block and you hold the chassis down and the motor in place as you screw it in, hopefully it should be dead right and you've checked it beforehand. But just make sure the motor hasn't shifted one way or the other and starts to hang down below the chassis. So we finished installing the motor and finished preparing the back end of the car. That's where we're going to leave it for today. So thank you again for watching. Please hit that thumbs up. Here we are, if I can hold my hand far enough away. Hit the thumbs up, please, underneath to say you like the video. Again, please keep subscribing. Please share this video. I'm happy for you to share it on any other platforms if you like what I'm doing. And I'll see you all again in the next video. Thanks for watching.